So essentially, if he made the basket, what's the horizontal displacement between the basketball player and the basketball net? And then the question is also asking us, what is the angle of the basketball as it enters the basketball net, essentially. So we have y initial equals 2.4 meters. So the ball is being shot at 2.4 meters. And then the height of the basketball net is 3.05 meters. We have a velocity initial of 12 meters per second. And then the basketball player prefers to shoot his shots at an angle of 35 degrees. So we can say that to find part A, the horizontal displacement between the player and the net, we can say y final equals y initial plus vy initial t plus 1/2 of a sub y t squared. Now, because we're saying that up is positive, that means that a sub y is going to be equal to negative g. So just keep that in mind. So we can say that 3.05 equals 2.40 plus, and then we'll say 12 sine of 35 degrees t, and then we'll say minus 4.9 t squared. And at this point, this is a quadratic equation. So we can just simply solve for t using the solve function in our TI 84, 85, or 89. And we find that t is going to be equal to 1.303 seconds. In order to find, for part A, in order to find delta x, we find Vx initial t, and we'll say plus 1/2 at squared. However, there isn't any acceleration in the x direction. So we can simply say that delta x equals Vx initial t, and this is going to be 12 cosine of 35 degrees, and then this will be times 1.303 seconds. And we are getting that delta x equals 12.8 meters. So essentially, the basketball player is 12.8 meters away from the basketball net. And for part B, to find the angle in which the basketball enters the hoop, we can say that Vx initial equals Vx final. We need to find the x and y components of the final velocity and then find the angle. So we know that the Vx initial equals the final velocity in the x direction. So this will be equal to 12 cosine of 35 degrees, and this is equaling 9.83 meters per second. We know that Vy final equals Vy initial plus gt. So this will be 12 sine of 35 degrees, and then we can say rather this will be minus gt. So we can say minus 9.8 and then times the t, so 1.303, and we are getting negative 5.886 meters per second. So now theta is going to be equal to arctan of the y component divided by the x component. So this will be 5.886 divided by 9.83, and we are getting 30.9 degrees. However, we need to specify that this is going to be below positive x-axis, so below the horizontal. Again, it's we have if you wanted to think of this as a Cartesian axis, we have a negative y component and a positive x component, which means that we're essentially in the fourth quadrant. So again, in order to specify that, we can say 30.9 degrees, and again, fourth quadrant would be below the positive x-axis. That is the end of the solution. Thank you for watching.